Looks like we're live. Hello everyone and welcome to yet another Abuzwozin session. Hello, welcome. So let's make a little bit of an announcement and officially start the stream. Of course. We can't start without that. Red circle live on Twitch. And what are we doing today on twitch.television? Today we're doing low-level graphics coding on Linux in C. I hope I actually put enough of the keywords in the title so people will click on it. And let me give the link to twitch.tv/studying. So this is the place where we're doing all of that. And I'm gonna ping everyone who's interested in being pinged, even though these days you can't declare that you're being interested in being pinged because the bot is dead that assigns the ping troll. So anyway. Yeah, so hello everyone, welcome. I can see people in the chat. So today we're gonna continue developing Olive C, which is the graphics library in C, how you can see, which is designed to do graphics, right? It's a simple graphics library that does all of the graphics in memory. Right, so the displaying of the graphics is outside of the scope of the library. The library just generates the graphics, and it's up to you what to do with that, you know, memory of pixels that it just filled in. So yeah, we've been developing this thing for quite some time, so let's continue. All right. So let me see. Today I wanted to work on something rather interesting. So we have a bunch of demos of the library, right? So you can find all of that stuff in here. So if you're interested, I'm gonna put this thing in the chat, and also for anyone watching on YouTube, right? So I'm gonna put that in the description as well. So this is the demos. So there's one particularly interesting demo, which is called Squish, right? So essentially what it does, it demonstrates the transformation of the textures, right? So essentially it takes a texture and just squishes and stretches and stuff like that. So it just demonstrates that. As you can see, it doesn't do any interpolations, right? So it's rather pixelated, but implementing a proper interpolation is, you know, is a separate issue that we're going to work on later, not right now. Right, so it only works for squares, right? So you can only do this sort of texture rendering and texture transformations only if you're talking about squares and no other shapes. So let's take a look at how exactly this transformation works. So let me open this entire thing, and I'm gonna go to Olive C. So the functions that do all of that, they are called Olive C sprite blend and sprite copy. The difference between these two functions is that copy literally copies the pixels of the sprite onto the canvas. Right, it just like literally copies. And a blend, it actually blends the pixels if the pixels of the sprite have semi-transparent pixels. For example, their alpha is, you know, half of 1 or something like that. So it properly blends things. And copy literally copies things. I really need you to separate these two operations because sometimes you may want to just resize the texture without doing any fancy blending. You just need to resize it so you can use this function. The logic behind these two functions is actually the same. It's just like how you treat the pixels. Maybe in the future I will be able to compress this duplicate code, but right now I don't really see how to compress it. So one of the ideas I have is to have some sort of a flexible mechanism of defining the format of the pixel. So you can easily say, okay, this pixel doesn't have a blending channel, so don't blend it, so the functions will never blend them. And maybe you can also will be able to define like where is the alpha channel located, how many bits it takes, you know, kind of like how SDL does that. So SDL, I think it has a surface, right? And surface defines the pixel format, and it's actually a rather complicated thing. It's user, yeah, pixel format, and pixel format, as far as I know, is the whole structure, right? Look at how many fields it has just to describe the pixel format, right? It has a enumeration that tells you what kind of format. Look how many formats it supports, right? So And then for different formats, it has different fields that describe where different channels go and stuff like that. So it's rather complicated. So maybe we're gonna have a similar mechanism that will allow you to describe the formats like that, or maybe we'll come up to like with something else. So that way you'll be able to say, okay, that specific format doesn't have an alpha channel, just copy whatever you have there. But this is just like, you know, I'm going on tangent anyway. So some of them even internal use, but I don't know. So essentially how it works, right? So how it works, I wish I could draw. Unfortunately, I'm not sure if I have a working tablet. Just, fuck. Everything's fine, everything's fine. All right. I think I have a tablet, but the cable of the tablet is actually kind of messed up, so I'm not sure if it still works, and I don't have money to buy a new one. Unfortunately, but it is what it is, and it isn't what it isn't. I do not deserve to have money. Alright, so... and I also don't have a place where to put that, so... Oh, okay, it works. Holy shit. That's actually super cool. Yusu, koi, freaking desu. So, what I wanna do, I wanna draw a rectangle, right? So here is the rectangle, and this is our canvas, right? This is our canvas. And we have some sort of a sprite. Right, so let me actually find the sprite. So this is going to be the colors, but maybe it's going to be a little bit brighter. I want it to be a brighter color. Thank you so much. Thank you, thank you, thank you. So this is going to be our sprite. This is our original sprite. And we have a rectangle within the canvas. I think this has to be a little bit pale, a little bit pale. Right. This is more of a destination. So this is a destination. There we go. So we have these three things. We have a canvas, we have a sprite, and we have a destination. All of these three things, they have different dimensions. Literally different dimensions. So, and essentially, what's the point of all of that? By copying a sprite into the destination, you basically take this entire thing and try to fit it into this rectangle. So if the rectangle is a little bit wider, you have to stretch the sprite. If it's a little bit thinner, you have to squeeze the sprite. And the same goes vertically, right? So essentially you basically tell the new dimensions within the canvas for that specific sprite. And this is why we accept three things: the canvas itself, the dimensions and position of the destination rectangle. X and Y is the left top corner of this destination rectangle, and width and height is of course the size of this thing, and the sprite. So this is how it basically works. This is the input for the algorithm, and what the algorithm does. And this is very, very interesting thing. So essentially what it does, it iterates each and individual pixel of the destination rectangle within the canvas, right? And as you can see, it has a width and it has a height. So, and at some point of iteration, right, you can say that it has a value X and Y, right? And the goal of this algorithm is, by knowing X and Y within the destination, to figure out the core of that pixel inside of this sprite, right? So basically you need to find the corresponding X and Y within the sprite. Okay, so how can you even do that? So essentially you can think of X and Y as values within the following range: 0, less or equal, less width. This is for X, right? This is for X, and just a second. For Y, it's 0, H, right? So here is an interesting thing. If you divide both of these things by w, so if you divide x by w and y by h, what you're gonna end up with, right, so you basically divide these things by 1 as well, is values from 0 to 1. From 0 to 1. Right. So essentially what we could do, we take x and y, we divide x by w and y by h, and we get a range from 0 to 1. So now we're not iterating from 0 to width and from 0 to h, we're iterating from 0 to 1, and we sort of normalize the coordinates. Right. We normalize the coordinates. Then if we multiply this value by the width of the sprite and the height of the sprite, we're getting back to the values from 0 to w and 0 to h, but within the coordinates of the sprite. So essentially what we're doing, like in this specific case, we are mapping the coordinates of the destination into the coordinates of the sprites, and this is how we figure out the colors of the pixels, and this is how we do stretching, squishing, and stuff like that. We're basically iterating within the normalized coordinates from 0 to 1. Does that make sense? So 0 to 1 range inside the rectangle, right? So, and you can clearly see how it works specifically here, but we have a little bit more complicated logic in here because the textures may actually a little bit overflow the canvas, right? But the basic idea is, you know, mapping the coordinates like that. So I think on a canvas it's not particularly great to explain because I can't really easily modify that. So I can say probably something like we have a destination x, all right, destination width, right, and here we have something like this. So we have two ranges. We divide both of these coordinates by destination w and destination h, which effectively divides those things by the same values. Right, and since we're dividing value by itself, we end up with 1, right? So there you go. And then after that, we multiply this thing by the sprite w and sprite h, which effectively results in this part also multiplied by the same values, and you end up with the values within the range from 0 to sprite w, right? So you start with these two things. By doing these operations, you end up with a completely new range, and this is how you map one range to another range. You see, in the text editor, it's a little bit easier to explain because I can easily transform these things. Within the, you know, drawing, it's kind of difficult to squeeze all of that. You end up with this kind of mess. So yeah, I just proved to myself one more time that some things are easier to draw, like, you know, graphics and stuff, but when it comes to formulas, it's just better to do that in a text editor, if that makes any sense, right? So yeah, I hope that's a little bit more clear what I meant in here. Do you have a book recommendation for learning C? No, I'm sorry, I don't have a book recommendation. In fact, I've never read a single book about C, so I can't help you on that. So you may want to ask somebody in the chat, probably, but yeah. What is ACM? It's a good question. Let's actually Google that. Association for Computer Machinery. Yeah. We see a world where computing helps solve tomorrow's problems, where we use our knowledge and skills to advance the profession and make a positive impact. Anyway, so that's ACM. So basically one of the things they do, they organize a CPC. That's what they do. It's an international collegiate, how do you pronounce this word? I don't know, I'm sorry, I don't speak English. Programming contest, right? So this is basically a programming contest for university students and also college students, right? So when I was in university, I was actually participating in that, and this is where I got this t-shirt. It's from 2012, 2013, so it was a long time ago, also 10 years ago. So it's kind of like worn out a little bit. So, but that's the only white t-shirt that is clean that I have right now. So here's an interesting thing. You may notice that I stream usually only in white t-shirts. Have you noticed that? Have you noticed that I only stream in white t-shirts? There's a very specific technical reason behind that. This is because the white t-shirt actually reflects the light better than any other of my t-shirts, so it just the quality of the camera becomes better because of that, because it becomes a little bit more illuminated. Right, so, and if I wear any other t-shirt, it's just like the quality is kind of bad. So the only reason why I'm wearing this t-shirt is because it's the only white t-shirt that is clean. Right, so all of the other white t-shirts, they're in the laundry, I'm sorry. So yeah, that's literally the reason. It's not like I'm trying to show off. Look, I've been doing competitive programming. No, I'm not a really great competitive programmer, to be fair. I'm actually kind of suck at competitive programming. So anyway, so let's continue. So here's an interesting thing. Essentially, what we're doing in here, we are working with sort of like a normalized values from 0 to 1. Right, we're working with the normalized values from 0 to 1, and this is not the only place that we're kind of doing all of that. Right, so here's an interesting thing. Remember how we were working with the triangles, right? Remember how we were working with the triangles, and we defined barycentric coordinates, right? And the barycentric coordinates is essentially the coordinates within the triangle, right? U1, U2, and U3. U1, U2, and U3. That basically have, I would say, the following properties. The sum of those things. The sum of those things is actually equal to 1, which means that all of these three values are sort of like within this range, right? So they are within this range. And if you take these values and essentially multiply their points, U2 plus P, P2, U3. I think I'm doing this stupid thing again where I'm trying to, like, you know, draw the formulas with the hand instead of a text editor. So, okay, well, let's do that again. We have U1, U2, U3. So their properties is that they're equal to 1. And also you have 3 points, P1, P2, P3. Right, and if you do something like this, P3, you're gonna end up with P, which is the point on the triangle, that specific point on the triangle. So this is basically the barycentric coordinates, right? So these are three values, the sum of which is 1, and they also basically define how close this particular point to the angles of the triangle, right? To the angles of the triangle. To the angles of the triangle. So, and essentially, here is an interesting thing. We can think of the coordinates of the sprite that we're drawing as normalized coordinates, right? So essentially, this is going to be, right, something like 0, maybe I'm going to put it like this, 0, 1, 1, right, 0, 1, 1. And what if, for a triangle, we associate additional coordinates, but the coordinates on that specific sprite, right? So something like maybe this one is going to be 0, 0, this one is going to be 1, 0, and this is going to be 0, 1, or whatever, right? And these are the coordinates on the sprite. And what if we do like the usual barycentric interpolation between these coordinates? And then instead of like interpolating the colors, we're gonna take the pixels of that sprite. That way we can actually map this sprite not only on another rectangle, but also on a triangle. This is actually kind of cool. Like imagine, right? So here in the squish example, right? So let me actually go there. So github.io. Here we're mapping square onto another square with different dimensions. Imagine if we could take a square and some parts would map it on a triangle using barycentric coordinates. This is actually kind of cool because it will work, right? So if we basically treat the coordinates on a sprite as the coordinates in normalized space from 0 to 1, and then for a triangle we associate additional coordinates on the sprite and do the barycentric interpolation, we're gonna end up with a thing in a triangle. We can map this texture into a triangle. So that should work. And this is precisely what I want you to implement today, right? I want you to try to implement that mapping of texture onto a triangle, because the only thing we need is just the barycentric coordinates. Hope that makes sense. All right, so I need to actually remove my Wacom tablet. And let's go ahead and do that. So let me see what we need to do. Maybe I'm gonna start with creating a demo. Right, I want to create a demo. It will be kind of cool to maybe take already existing demo. Right, so Olivets. Right, because we already have something like this. So we already have a triangle. Maybe I'm gonna copy paste this triangle. Right, I'm gonna copy paste this triangle, and instead of doing the how is it called, the gradient, the color gradient, I'm gonna actually map a texture onto this thing. All right, so let me see. So this is the triangle, and I'm gonna copy paste it and say triangle texture. Right, so maybe I'm gonna put text C. There we go. So this is a triangle texture. Here's an interesting thing. I don't think I need a circle, right? So I'm gonna remove everything related to a circle. And let me also build this entire thing. So this is going to be triangle tag. And let's actually disable the building of everything else. So it's a little bit faster. So it's a little bit faster. So we don't need a circle. I'm removing the circle. It actually took quite some time. Maybe because I'm doing the tests. So let me quickly try to get rid of the test as well. So we're also building the assets, right? Neither the assets nor the tests are needed in here. So we're gonna only build in the text. Okay. So and let me try to do triangle text SDL, and there we go. So as you can see, we only have a rotating triangle in here. Right, so here is the thing. Though we probably do need some of the assets, right? So we probably need the TTHATPAWG, right? So what we're doing here, we just take the image, right? We just take the image and we turn it into C, which allows us to bake that image into the executable, right? So let me actually rebuild this thing one more time. Let me actually do it one more time, and if I open the assets, so here is basically, this is the image, this is the pixels of the image as an array. So then I include this thing into the application, and now I don't have to read anything, it becomes baked into the executable, and this is done by the utility called png2c, which I wrote myself using STB libraries and stuff like that. So basically it just loads the image, uncompresses the pixels, and just generates the C code out of the pixels. It's actually rather convenient. and it's super easy to write yourself if you want to, right? So it's actually pretty easy for everything. Alrighty, so demo, let me see. So one of the things I want to do, so we don't need circles. I want to include assets, sodium.pog, right? Sodium.pog.c, there we go. So we now can have that, right? And I can try to rebuild this entire thing just to confirm that, you know, all of that is working, all of that is working. So triangle, here is the function that we use to fill the triangle, right? Here is the function. One of the things I probably want to do, right, is essentially being able to specify the coordinates in here, right? The coordinates of the texture. And by the way, those coordinates of the texture, like from 0 to 1, are called UV coordinates, right? UV coordinates. So these are UV coordinates. So UV mapping. If you ever heard this term, this is basically what they are, right? These are the coordinates within the texture, but they are usually normalized from 0 to 1. And you can use those coordinates to interpolate using different interpolation. You can use the linear interpolation like we did with the rectangles, right? So this was the linear interpolation by width and by height. You can use barycentric interpolation. Is that even a term? I'm not even sure. Just to do like a triangle interpolation. Yeah, you can just easily interpolate between these things and then sort of like, you know, feed that texture onto some sort of a surface, right? So that's basically the idea of UV mapping, and that's basically what it is. And the reason why I explain that is because I want to have something like make UV, right? So I'm going to say that this particular angle of the triangle is going to be 0, 0. This one is going to be 0, 1, and another one is going to be UV 1, 0, and which will basically distort the texture and try to fit this entire thing into a triangle. But that's kind of the point of what we're trying to do, right? So, and by the way, I'm going to copy paste this thing in the chat. And also, I'm going to put this in a description as well, right? So this is basically UV mapping, if you're interested in this entire thing. Okay. All right, and the thing is, we're doing this stuff on a canvas, and a canvas can only store uint32. All right, so let me go to here and let's take a look at the canvas. Olivet's canvas, and as you can see, it's uint32. But now, instead of the unsigned integers 32 bits, we have to store there a vector of 2 values, of 2 floats, right? So the u coordinate of the texture and v coordinates, or x and y, right? So we already had a similar problem when we were implementing the z buffer. Do you remember that? Right. So because we had a demo. So let me do searching GitHub.io. And yeah, this is the demo that we were doing, and we needed to implement a z buffer, which instead of color pixels, stores the z value of which individual pixel, right? And the z value was a float. So what we did a little bit of a type punning. So essentially, we stored in the 32 bits the 32-bit float instead of integer, but we still had integer in here. So basically, depending on the function that you use, the function will interpret these pixels differently. Maybe we're going to do the same thing to store a 2-dimensional vector in here as well. But this is the problem. Before, in case of the z buffer, we were storing 1 float. But now, we need 2 floats. And single float is 32-bit value. So we need 64 bits. So the 2 floats are not gonna fit in here. They're literally not gonna fit in here. So that means we cannot just use the same trick as we did with the z buffer. But here's an interesting thing. On the stream where we were implementing the z buffer, somebody suggested to store values in the pixel. Instead of like floats, store a value from 0 to uint32 max. Right, so inside of the pixel, just store the value from 0 to uint32 max. And uint32 max is the maximum value that it can be stored within uint32. Right, and the idea is that when you store this value in here, you're actually storing z, which is basically v divided by uint32 max, which kind of fits the whole theme of the library, because inside of the library we don't even use any floats at all, except for, you know, for the z buffer, because I didn't see any other way to do that, but now I see the other way to do that. Right, so z is actually that value v, but divided by uint32. And the whole theme of the library is that even like barycentric coordinates, right, they don't really return you the values from 0 to 1, they return you u1, u2, which are just arbitrary values, plus the determinant that you have to divide this value by yourself. Like everything is done in integers. So, and this is a very interesting idea. Right, maybe at some point I'm gonna actually change the z buffer implementation to do something like that, but it requires time, so I'm not gonna do that. How can we use a similar thing for UV coordinates? How can we use this similar trick to store two-dimensional things? We have 32-bit value. It's 4 bytes. Byte 1, byte 2, byte 3, and byte 4. What we can do, we can split that 4-byte values in two and essentially allocate first 2 bytes for the x coordinate or for the u coordinate, right? So this is going to be u coordinate, and the second 2 bytes for the v coordinate. And what in fact we're storing in here, so let's actually call them something like a and b, right? So let's call them a and b. We're storing u as a divided by uint16 max and v uint16 max. So it's kind of a similar trick, but yeah. Does that make sense? So essentially within a 32-bit value, we're storing UV coordinates from 0 to 1, but we're actually storing the, how is that, numerator, fractions, numerator, denominator, right? So, yeah. So we're essentially storing numerators for these things, right? And when we need to do the actual mapping, we just like keep that in mind. Right, and once we implement that, then maybe I'm gonna go back and implement the z buffer similar to this kind of thing. I don't remember who suggested this idea, but this is actually a very cool idea. Whoever suggested this, if you're watching this right now, thank you so much, you're a genius, right? This is so cool. And this actually extends to more things, right? So it extends to more things like in here. Casts plus pointer arithmetic C approved. I don't know, the only reason why we're doing all of that is because C sucks, right? If we had like a proper language, maybe we could do that with sort of like generics or templates, right? So if I was using C++, and I'm not saying that C++ is a normal language, right? So C++ has its own problems, right? If I was using C++, I would just make a canvas a template so I can replace the representations of the pixels and still leave the functions with the same implementations, right? So I would do something like that, but unfortunately we're not doing C++, or maybe fortunately, right? Because I mean, here's the interesting thing. C++ is sort of a trap, right? So essentially you may look at C++ and see, oh, okay, so it solves some of my problems that I have in C, so I have to switch to C++. You switch to C++ and you open a can of worms of other problems that you never cared about and never had. And now you have to deal with them instead. Right. So it's actually very deceiving. You may think that, oh, okay, so C++ kind of fixes those problems. No, the price of fixing those problems is usually actually quite high, and you need to be ready to pay that price. I'm not saying that you shouldn't do that, but you need to be aware of the price, right? Because as soon as you start using C++, you open like the Pandora box, right? So the same with Raspberry Pi. Anyway. So, and the only reason why we do this kind of stuff in C is because, well, we have no choice. You can fix that by switching to other languages, but in other languages you're gonna have more other problems. Right, so yeah. Okay, so yeah, let me see. And remember how I was talking about like a sophisticated mechanism for defining the format of the pixel? Maybe we should design this mechanism so it's flexible enough to be able to instruct to treat these uint32s as either colors or z values or uv values, right? Because in SDL, right, SDL surface pixel format, in SDL pixel format only assumes that you store colors. What if we design a pixel format mechanism that allows you to define not only colors but also arbitrary values with arbitrary formats, like z, the numerator of z, or the UV coordinates as well. And that way you may have probably like a single triangle function that just does interpolation how the pixel format describes. You know what I'm talking? I know that I'm just hand waving. This is a very abstract description, but this is sort of like a direction towards which I want to move, right? So you have these, you know, abstract functions, and then you have a separate mechanism that describes how to treat and interpolate those values, regardless of whether they're actually colors or something else. What I'm saying is that we should move towards the fact that Canvas is not necessarily storing colors. Maybe it's storing any values that are interpolatable, and you have something that describes how to interpolate those values. This is actually very interesting. So again, I don't really know the details of how to do that yet, but this is sort of a general direction. Right, because as you can see, the more features we implement, the more it becomes obvious that this is not only pixels. Right, because who said that it's only colors? It's just, color is just an interpretation. Right, it could be a z value, a depth. It could be a coordinates on a texture. It works the same. The math is the same. So I think we need to move towards that. But again, the problem is that in C, right, we don't have a templates, we don't have a code generation, we kind of stuck with the cells of the fixed size, right? So, and we need to come up with a format that fits all of that shit into like a very fixed box. Even more generic, like, but yeah, and we're starting to hit the limitations of C like very, very hard, unfortunately. Unfortunately, but it is what it is, and it isn't what it isn't. Is it not? I think it is anyway. So 3C, so this is 3Z, and let's actually introduce another one, which is going to be 3UV. Right, so in here we accept the coordinates, and then we need to accept the UV coordinates, right? So I'm going to say U32T. This is going to be UV1. Might as well use a little bit of Emacs magic. uint32, right, like so, and then UV. Furthermore, we can try to do the following thing. Who said we can't create a structure called UV, right? So maybe I'm going to do it like that. And here we're going to say uint16a b, or maybe UV. There you go. And then we need to make sure that the size of the structure is actually 32-bit. Right, so, and when we store something in the canvas, we're going to be basically reinterpreting integer as this structure. That way we don't have to do any bit fuckery, if you know what I mean. Alright, fuckery, that's what I wanted to say. I don't speak English really well, I'm sorry. So, and because I didn't really stream very often lately, my pronunciation is actually kind of bad. You see, I need to get used to speaking English again. It's kind of difficult. And it's kind of dangerous for me to speak English right now because my neighbors may think that I'm a Western spy. And then they can call KGB and they will put me in Gulag. So yeah, I have to be super dangerous. Monkers, yes. So Ramon, what's up? So yeah, I'm spreading American propaganda right now. Anyway. So let me first probably check size of your UV, not your mom. Okay. And in here, what I want to do, I want to include stdio, and I'm going to include Olivets. Define Olivets implementation. Right, and this is going to be return 0 and void. And in here, I want to do size of UV, right? Printf ZU, and let me see if it's going to work. GCC, not GCC, let's actually do clank, check size. And there we go. And it's actually 4. As you can see, it actually fits U32. Maybe I'm gonna do the following thing, because I'm not really sure. So the compiler is not supposed to pad that, right? It's not supposed to pad that, but anyway. GCC. GCC. Not GCC, but GCC. Okay. So, maybe I also need to introduce make UV. Militab, thank you so much for 9 months. Thank you. I really appreciate the support. Okay, let me go to. I want to go to the this thing, right? And I'm gonna do UV make UV. And we're gonna just, put these things in here. uint16 v. Though usually, if it's part of the library, I need to do the Olivets UV. Maybe I'm gonna just call it Olivets UV, because why not? Right, Olivets UV, and that means I also have to do Olivets def, right? So maybe I'm gonna put that stuff near here somewhere, but it's kind of whatever. UV and just return this entire thing. There you go. And instead of make UV here, we're gonna be doing Olivets UV. From 0 to 1, this one is rather interesting, right? Since we're storing numerator for that fraction, right? So instead of 1, we have to do uint 16 max, right? So that's what we have to do, uint 16 max. So we have to be aware of this entire stuff. So something like this, and that, and that. Okay, there we go. All right. So, and now I probably need to copy paste this thing. So I'm just thinking what's going to be the best way to do that. So I think I'm going to just copy paste the Z implementation, right? And just going to use UV here instead. So this is float, UV, there you go. And this is quite important. So I already had this problem in the previous stream, so I have to not forget to change this kind of stuff, right? So this one is going to be UV. Right. There we go. So I might as well just go and recompile the whole thing and follow the compilation errors, right? So we're going to be following the compilation errors and see how it goes. All right, so this is Z1, U1. So that makes sense, sure. And this is the interpolation. So what's going to be the best way to do that? Right, if we isolate a single thing in here, right, if we isolate, we have to do UV1 U multiplied by, you know, this thing and divide by the determinant. Okay, that makes sense. But then I'll have to turn that into UV coordinates as well. So then here I have to do this kind of thing. And since I'm doing the sum, I have to do the same thing for the second coordinate as well. So it has to be something like plus, but this one has to be 2. Yeah. Okay, so that gets a little bit more complicated. And then this is going to be the third one, but with the third one it's a bit different, I suppose, because there's no U3. Or maybe it should be. Maybe it should exist. Maybe we should define U3 as the determinant minus U1, U2. Right, precisely the thing that we're doing here. So this is going to be U3, and it will make it a little bit easier. So, and the final UV is basically this, right? This is the final UV, which we have to store in here. In fact, we don't even have to do this kind of thing, right? So we have to we have to convert to int32, right? So we take this new UV, we take a pointer, we reinterpret the pointer to int32, and then we store it inside of the pixel. Ceremon's a Sprite at tier 1. Thank you so much for the subscription. I really appreciate it. All right, so yes, so this one is more of like an integer, and there you go. So this is basically what we need to do for the UV coordinates, right? I wonder if it's gonna work or not, and I'm just a little bit worried that maybe we'll lose a little bit of information by early dividing by the determinant, but we'll see how it works. Right, so it would be better to actually do something like this, where we just do it like that, and only then divide by the determinant, but I'm a little bit worried that it's gonna overflow, right? So I'm just like a tiny bit worried, but we can always just like, you know, do something like this where we cast the 16-bit things into integers, right? And then we cast them back. We'll see how it goes, but maybe it will work. Right, so something like that. This is like the basic idea. And of course, when we are scanning the triangle, we actually have 2 separate loops. So we have to copy paste this part to the second loop as well for this entire thing to work. There we go. So let me try to recompile this entire thing. Of course, it doesn't work because we have some weird stuff in here. So let me fix that. Oh, this is the second one. I can't really see that properly. And UV to the parameter of uint. Okay, so here we have to do UV, right? So this is UV. And this is kind of an interesting thing. So essentially, we're rendering all of that. Into a separate thing. Just realized something interesting. So, okay, we rendered all of that into a separate UV buffer, but then we have to merge that buffer with the original canvas. How are we going to merge that? To merge that, we also have to determine what pixels are not part of the triangle. And it's kind of difficult to achieve that. So maybe this is not a particularly great idea. What if we supply the texture in here, right? What if we supply the texture? So let's actually take at sodium pog, Olivet's canvas, pixels. I forgot how, what is this thing? Build assets, sodium pog. Right, so here come the pixels, sodium pog pixels, sodium pog width, sodium pog height, sodium pog width. There we go. So we have something like this. So this is the canvas. Maybe we should supply this thing as the texture, and so it renders those things in place. But that also means that you don't need this trickery with the UV coordinates or anything. You just don't need that anymore. Right. You just don't need that. All right, so, but we may need that in the future, right? We may need that in the future. But for now, I'm just gonna leave it as it is. So, yeah, here we're gonna supply the texture, Olivet's canvas texture. Oh, I already called it a sprite. Let's call it sprite then. Well, I mean, in case of you, it's better to call it texture, I think. Yeah, we'll see. So, Olivet's canvas texture. And instead of storing this thing, we're gonna try to store the color, right? So here we have UV U. All right, and this is if we divide this thing by uint 16 max, we get a value from 0 to 1, which we simply have to multiply by the texture width to get the coordinate within that texture. But here we can have a little bit of a loss of information because we just do the division, so we lose the fractional part. So it's better to multiply it first and only then divide. But then we have a little bit of a risk in here that this thing is going to overflow because it's uint. And this is size t. So maybe I should actually first cast it to size t. And that way, I think we get the proper coordinates. So we can say this is a texture x, right? This is a texture x, and here we're gonna have y, v, height. So, and then we can do Olivet's pixel, texture x, and texture y. There we go. So yeah, essentially instead of like storing that in a separate buffer, we just like pick the pixels out of the texture right away. But I still want to preserve the ability in the future to have a separate buffer of UV coordinates because it's going to be useful in the future. You will see why. Or maybe not, we'll see. So all of my streams are exploration anyway, right? I'm basically showing you my raw process, right? How I design and come up with things. I just try them and see what goes wrong and what not. And yeah, just pick the thing that works, essentially. All right, so what do we have in here? I don't quite see. Okay, so there is an A in here. And there is an A in here. All right. So, okay, so it seems to be working. It seems to be working, and it should actually already work because I think that is basically it, right? I think that is basically it, and let's actually see if it's going to work at all. Right, texture. I don't see where is triangle text. Yeah, I forgot its name. It's a triangle text SDL. All right, very interesting. I mean, it shows gibberish, but it's a rotating gibberish. Just think for a second. Okay, so yeah, it's wrong, but the colors are from the texture. The colors are from the texture, and the gibberish is actually consistent within the rotation. And all of that without using OpenGL or anything. Well, the entire idea kind of close. That's actually very cool. It's a promising gibberish. Yeah, it is in fact a promising gibberish. All right. So that's very, very interesting. Okay, let me see. So it's a 0. If it's a 0, then 1. So this is another one, and this is another one. Might as well just, yeah. I'm gonna keep all of that as it is. So let me try to look into this thing and try to understand what exactly is wrong in here. It might be because of this thing somewhere here overflows, and this is what I was worried about initially. So let's actually go back to this idea where I just like divide those things a little bit earlier. Right, so this is the first thing. So Azura Kimura, thank you so much for 7 months. 7 months of the Epic C Clubs. Thanks for all the fun streams and programming inspiration. Will wishes from the US. Thank you. I really appreciate that. All right. I'm really glad that I'm still able to inspire people to do things. Right? All right. Cool. So I think I need to do the following thing where I just like rebuild this entire stuff. Rebuild this entire stuff, and yeah, so it doesn't really matter, right? It does not really matter. So I'm gonna try to sort of like debug it by looking at it, right? So I'm gonna try to debug it by looking at it. And I interpolate those things. I think I need to make a small break. I already streamed for 1 hour, and I would like to make a cup of tea because I need to caffeinate myself. So, and while I'm making tea, I'm gonna try to think of what exactly goes wrong in here. And yeah, so let's make a small break. All right, so I think I kind of have a couple of ideas on what is going on in here. Right, so essentially, what we need to do, when we have U1, U2, and U3, we're actually not dealing with values from 0 to 1. We're dealing from values from 0 to determinant. So in fact, if we want to treat them as barycentric coordinates, we have to think of them as like this, right? So these are the values. And in case of UV coordinates, right, we're not really dealing with UV. We're kind of dealing with UV divided by uint16 max, right? So this is UV1, and let me actually do something like this. So we have to treat this stuff like this, right? And because of that, okay, so let's actually do the multiplication, right? So when we do multiplication, we essentially end up with something like this, where we then divide by the determinant and then divide by... Okay, so we kind of missed another division in here when we were doing this thing. So as you can see, we do a division by the determinant, but we don't do the division by uint16. And that actually kind of explains the tiling pattern. Right, because what we have to do, it's too big, the value is too big, it starts to loop around. So that actually explains it. Okay, I think we found a problem in here. All right. And the components in here are basically those things. It's just accept 1, it's going to be 2, right, and this one is going to be 3. All right, so that's the power of a break, but I'm not sure if it's gonna work or not, but at least it makes sense, right? So it kind of makes sense now. So yeah, so essentially we can clearly see that the only thing we need to do here is just additional division by u in 16, right? So that makes sense in my opinion. Like so. Boom, and then a boom. There we go. Of course, we can actually, you know, generalize that, so put it outside of the parentheses or something like that. You know, the usual thing that we usually do, the usual things that we unusually do. Man, I love making usual things unusual. All right, so hopefully that will do the trick, and that didn't work. That didn't work at all, but we have a color. We have an interesting color, which is the color of the background, right? So if we take a look at the asset, right, so then POG, so that's the color of this thing, right? So that's the color of this thing. So yes. So maybe, just maybe. What if we take a look at text.c? So this one goes towards another one and then goes towards another one. What if I do u in 16 max? U in 16 max. It didn't really change much, so that's totally fine. Maybe there is a little bit of overflow somewhere here. It could be the case. It could be a simple case of overflow. And if it's the case of overflow, maybe we can try to do something like this. Shouldn't be the case though. 6-14. Okay, so what I'm thinking is that maybe let's try to make it work with floats, right? Because working with like purely in integers is a little bit finicky. So, and since we decided that for that specific case, we don't really need to store the UV coordinates in the canvas, right? We don't need to store that in the canvas. Let's actually try to do all of that in floats, just to see how it's gonna go. Right, just to make it working, right? So we may go back to the, you know, packing that into the integers, but for now, let's just keep it in floats, right? Because I want to make it work, right? So let's go through the compilation errors. Hopefully that will create compilation. It didn't create compilation errors. This is actually quite worrying. All right, so essentially what I need to do in here is just replace this thing with once. Right, so these are once. 3 UV. 3 UV. So we sort all of that stuff. We just sort all of that stuff. Okay. Lord Horacio, thank you so much for the sub. Thank you. So here's the UV coordinates, right? So we divide that, we multiply it by u, and then we divide it by the determinant. Okay, so, and because it's from 0 to 1 anyway, we don't really need to do any of these divisions, right? So none of that is required anymore. So all of that stays kind of float, right? So then we do, oh yeah, so then we just do this kind of thing. So we take UV coordinate, And we don't need to do this division, right? We just multiply it by the texture width, right? And then we just treat it as an integer, and there you go. Right, so we can try to do something like this. Texture width and texture height, then we just copy the pixel from one place to another place. Right, so let's copy paste this thing in here. Okay, go. So let's see if it's going to do at least something. And it worked. Right, so, and as you can see, we managed to actually fit the texture into the triangle, which is kind of cool. So essentially, the problem was with using integers, so maybe something was overflowing there, or something else, I'm not quite sure. So something was definitely going wrong. But that's kind of cool, right? And it's also rotating. It is also, in fact, rotating. So, you know what's cool? We can essentially construct a mesh consisting of two triangles that form the square, and then we can set up its UV coordinates, so it again a square sprite. But the cool thing about that square sprite is that you will be able to rotate that square sprite. You know what I mean? You'll be able to rotate it. That's kind of cool, isn't it? I think it's kind of cool. Yeah. So essentially, you will be able to do all sorts of like different transformations. And again, this is without using OpenGL. This is manual pixel by pixel processing. That's what I like about it. It's so fucking cool. Can you SDL rotate sprite? It actually can. Let me show you. SDL copy. Render copy. I think it's a render copy X extended. Yeah, it's a render copy X. Yeah, you can provide the angle. You can also provide the center, the pivot of rotation. It will actually rotate those things. So it can do that. It can also flip those things around. But... how much CPU? It probably takes a lot, actually, CPU. But we can see in just a second. Alright, I'm gonna show you the top, but I have to be a little bit careful. Just a second. I can't just show my top. I can't just show you my processes. Come on. Okay. What is that? Triangle. Where is the filter? Yeah, there we go. So it uses 100 CPU, right? So it uses 100 CPU. But does it use the 100 CPU because it's doing heavy processing, or is it because it's busy looping? Right, you have to answer that question specifically. Is it just busy looping? You can easily check that by doing the following thing. Demo VC main, where is that? We don't even delay anything within the main loop, right? So there's nothing delaying in here. So we can always do use sleep, something like one. What does it say? It's like, yeah, we can sleep for 10 milliseconds, right? Just a little bit, just sleep a little bit, a tiny bit. Okay. And then if I go to htop and then take a look at triangle, and now it is taking half of the CPU, right? But I didn't even try to optimize that yet. So optimization of this entire thing is actually kind of outside of the scope right now. Yeah. Anyway. Oh, right. That's pretty cool. So let's actually try to make a rotating thing. Let's try to make a rotating thing, and I'm thinking what's going to be the best way to do that. I think what we need to do, we need to generate 4 points, right? Let's try to generate 4 points. so we have x1, 0.1, 0.2, 0.3. Maybe we need to have more of those things. Right, something like 4. Right. And because of this, I'm thinking, let's call it PS, right? We have 4 points, and each point has 2 coordinates, right? All right, so I'm gonna iterate from 0 to 4. Right. PSI, and what do we have? So 0 is gonna be x, right? X is cosine, cos f. Then we have an angle, right? So the angle is going to be half over pi, right? Half over pi multiplied by I, right? So this is half over pi multiplied by I. Then we have to go from the center. Center is the width divided by 2 plus this thing multiplied by some sort of a length, right? So this is some sort of a length. Then here we have a height, sine f, and that should be it, right? And that should be it. So we have 4 points in here. So we've got 4 points. Cool. So what we're gonna end up with, so the next thing we need to do, we need to draw 2 triangles, right? So we need to draw 2 triangles, something like this. 4 size t, 2 plus plus I, all right. 2. So, and I'm going to be drawing just triangles with the color. Right, well, we can actually use the following thing. How many colors do we have? Colors I. Right, so this is the colors I. So, and in here, we just have that. Static. Maybe this doesn't have to be static, but the colors are going to be the following. We're going to have 2 colors. The first color is going to be red. The second one is going to be green, so we can clearly see those colors. Right, and in here, what do we have? We just have PS 0. Right, so PS 0, X is 0, PS 0, 1. So here, this is 1, and this is 1, and this is 2, and this is 2. What's interesting is that I need to draw. Right, so we just go from one thing to another. This is the first triangle. 1, 2, 3. So this is the first triangle. And then we have to do 3, 2, 1, 2, 3, 1, 2, 3, 4, 3, 4, 1. So, which means that we have to do something like I plus, but then it may overflow, which means that we have to mod it by 4. Right, we have to mod it by 4. And that will result with 2 triangles. So essentially we tessellated the square. I think we can think about it like this. Okay, so that didn't compile because we don't have such thing as len. Right, so let's define len as something like, I don't know, half of a width or something. I don't think it matters that much. So we have some other things. Oliver's triangle 3, I think it has to be called C because we're talking about, well, are we talking about specific color? I don't quite remember. Triangle. Oh, it's just called triangle. Yeah. All right. Triangle and this one. All right. Okay, that looks like shit. I'm really happy. Okay, why did it end up like this? Why did it end up like this? So it's less than 4. So I need to draw, that means I need to draw. All right. So just a second. Man, I wish I had a better, like, working. I mean, my tablet working, but I mean, it just has a fucked up cable. It's really inconvenient. All right, so we have. All right. So this is 0. Then we have 1, 2, 3. So this angle is half of a pi, right? So this is a half of a pi, so that makes sense. All right, the next thing, I need to draw a triangle from 0, 1, 2. Right, it's a 0, 1, 2. Oh, it's a +2. Yes, yes. Yeah. So this is 1. Right, and then what I have to do, maybe multiply this thing by 2. Because that's kind of weird, but that's probably what I need to do, yeah. That's probably what I wanted. All right, so it's going to be by 2, and then it's going to be 2, 3, and then it will circle back. 2 plus 2 is going to be 4, and it's going to be okay. So I think I found the mistake. Yes, that works. That actually works. Interestingly, we also have a triangle angle, and this is probably what I need to put in here. Plus triangle angle, and let me divide this thing by 4. Right, so I think that's going to be a little bit better. Okay, so this is what we have in here. That's cool. That's precisely what I wanted. That is precisely what I wanted. Okay. So essentially, I constructed a square out of the triangles. That's what I wanted to do. That's what I was aiming for. Now I need to do 3 UV. Right, 3 UV, and now I need to come up with the UV coordinates. So how we're going to be doing all of that? Interestingly, well, essentially the first one is just like we have to take this thing, right? It's going to be 0, 0. Yeah. We kind of need to have 3 indices. Right, the index 1, the index 2, the index 3. And we... Okay, this is I1, I2, I3. And this will already kind of contain the UV coordinates in a sense that we can Olivet's UV I1. I just take this thing and then yeah, something like this. Okay, and this is going to be the second one, and this is going to be the third one. Yeah, we can do something like this. Something didn't compile properly, and expected, yeah. Still doesn't compile to few arguments because we have to provide the texture. Right, so we have to provide the texture that we are rendering, and okay, it's segfaulted. That's actually super cool. I'm really happy. I'm really happy to see that it successfully segfaulted. The question is where exactly it's segfaulted. Also, probably want to do something like this. Something wrong in here. All right. Oh, that's cool. Look at that. This is precisely what I wanted. No, it's actually... They're looking into each other's eyes. Wait a second. Can I just not do that? Can we just not rotate them? Let me see. What if we do triangle P4? Oh, this is not plus, it has to be equals. This is not plus, it has to be equals. Actually, and then plus pi. Right. I really like this thing. So it's just like, it looks like the right one leaning like really close to the second one and say like, isn't that POG? And this was like, it's POG, it's POG. I really like that. Yo mate, isn't that POG? Isn't that POG? Isn't that POG? Oh, this has to be its own emote. Like, Tojin, isn't that POG? Isn't that POG? It's just like, it's really violating the other one's like private space. It's just like it really close towards it and looking into the eye. That's so funny. I really like that. Isn't that POG? I think it's pretty POG. Oh, I wonder if we can save that as a PNG. I really want to save that. The question is, how are we going to be doing all of that? That's a good question. So first of all, we need a square canvas if we want to save that as a PNG image, right? So, but we don't really have a square canvas, unfortunately. So let's do the following thing. I'm going to say this is a square canvas now, and there's nothing you can do about that. Okay. So it is in fact a very much square canvas, sure. Let's actually make it slightly smaller, maybe 128, right? So it's a still power of 2, but it's just like, yeah, like that. Okay, so we can clearly see, and now let's actually try to make it the image as big as the whole canvas, right? So that means we'll have to make the width half of the width. Length has to be half of the width. Right. There we go. Which didn't really work. You know why? Because we're generating this thing by rotating. So that means, ooh, this is kind of fun. So this thing has to be actually half of the width. This is half of the width. But maybe it has to be square root of 2 of width. You know what I mean? Yeah, because we're generating this thing like so. So that means this stuff, this radius has to be the len has to be equal this stuff, this diagonal. If you have a square, like, right, you have a square, A and A. So what's that thing? A, so this one is going to be, diagonal is A squared plus A squared, like that. And also divide by 2, right? So it's actually 2. So it means the length is A to, right? I think something like this, right? So that means we'll have to multiply the shite. I have to multiply the shite by sqrtf to make it. I think we want to be precise. Yes, it works. It works. Next thing we need to do, we need to save that, right? So do we have stb image right? We do have stb image right. Right. So I'm going to include third-party stb image right.h, and we also have to do something like stb image right. Is that how we do that? I don't know. Sorry. Third-party stb image right. 6 stb. We have to put this thing in here. There we go. stbi. Yeah. And now, after we rendered a single frame, right? We rendered a single frame. I should embed an ability to do screenshots into the demo. Right, I think this is something I have to do, but that requires making some changes. That requires writing code. I hate writing code. Sodin isn't that POG. Right. POG. This is going to be width, height for OC data, width multiplied by size of uint32t, and we have a result, right? So this is a result. I'm going to assert that result is okay because I'm too lazy to check for proper errors and report proper errors. I just couldn't care less. I'm sorry. I'm a very bad developer who doesn't handle errors at all. Why the fuck would you need that? Okay, so stdlib doesn't. Oh, this is because I'm trying to build for WebAssembly. Alright, so let's not build for WebAssembly then. Who needs WebAssembly in 2022? Right, we're not building that. Well, I can build a terminal because why not? I can do that. I can afford. Well, what the fuck do you want? It's not data, it's pixels. It's pixels. A boom. You should say a boom. Okay. Yes, we have that. I wonder if I can just go to BTTV or wait a second. Can I just add this emote right now? I want to add it right now, chat, but I forgot how to do that, and Twitch recently changed so many things in the panel, it's unimaginable. And their website is slow as... It's slow as your mom! Okay. Emotes. Oh yeah, I found it. I'm just afraid that I'm gonna just show something. Something. Tier 1. The fuck? I have 4 additional slots. I have 4 additional emote slots. What a fast website. Okay, so look. 4 open slots. Okay, let's actually add a slot. So these days I can just like upload and don't worry about shit, right? So that's the state of Twitch right now. Sodin, what was it called? Olivet's Sodin isn't that POG. Okay, isn't that POG? And where is the image? I didn't see the freaking image. Please support our community of artists by uploading an emote you are saying you believe to the best of your knowledge that you have the rights to use and share it on Twitch. Well, I wrote it. I mean, I drew it. Okay. It's barely readable. It's barely readable. But it's there now. So I wonder if it's already working. It's already working, isn't it? It's actually so funny. Is that POG? Is that POG? Oh, is it that POG? Dude, is that POG? Oh. I like that. I really like that. Right, so let's continue. So obviously we fucked up the UV coordinates, and I wonder why. I wonder how. I wonder how, I wonder why. Yesterday you told me about the blue sky, and all that I can see is just a yellow lemon pea. Okay. Alright. That takes a lot of time to compile, unfortunately. Yeah. So if we need to go back to the drawing board, right? 0, 0, 1, 0, and the next one has to be 1, 1. I think I just need to do that in a proper way, right? So let's do something like float UVs 4, and it's gonna be 2, and I can just do that, of course. I can just do that. 0, 0, then 1, 0. All right. But the next one is gonna be, it has to be like 1, 1, and the last one has to be 0, 1. Right. So then here is essentially we just do. I might as well just use it as UV. All right, and UVs. Right. Okay, so something went wrong. So just braces around something. Oh, I think in that case I just don't have to do that. Oh, and since, okay, I see what's going on. So let me say I just have to do it like this. Okay, it works. So it's actually like properly assigned, so UV coordinates are okay. The next thing we have to do, let's actually go back to the original thing with something. So we're gonna actually divide it by 4, and we're gonna bring back to rotation. All right. And it's slow as fuck. That's actually super cool. Isn't that cool? Isn't that cool? I think it's pretty fucking cool. But it's rotating. It's actually rotating. Time to go faster, 144. Yeah. And I wonder if we switch completely to integers, would it be actually a little bit faster, right? So it's probably because of the like constant conversion of floats and stuff like that. But I achieved the goal of today's stream, right? I wanted to actually do the mapping of the textures for the triangles, and we did that. The next step would be to actually do all of that in 3D. All right. You may say that, oh, okay, just like slap that on a 3D example that we had, right? So basically build triangle 3D and call it a day, but it's not going to work actually. For the same reason why just interpolating Z in the Z buffer as it is won't work, because of the projection. The projection is so fucked up, you have to interpolate 1 over Z instead of Z. Because in the projected space, Z doesn't change linearly, but 1 over Z does. So the same way, when you projected the triangle, the UV coordinates on the screen don't change linearly anymore. You can't use the linear interpolation. And what you have to do is to basically linearly interpolate UV over Z. So you interpolate it and you have to divide it by Z as well. So you need to project UV coordinates on the screen as well to achieve the 3D effect. And that's why we'll need both the Z buffer and separate buffer of UV coordinates. And that's why I wanted to do that, because ultimately I wanted to do the 3D thing. Right, but we're already kind of like out of time to do that, so I'm probably gonna do that on the next stream. But for today, I think we achieved a pretty good result, right? So we managed to map that on the triangle and it's slow as fuck, but yeah, we'll see. That's pretty cool, actually. Maybe eventually we're gonna re-implement like the whole OpenGL, who knows? Of course it's slow, but I mean speeding up is gonna be a separate story. Because I have a lot of plans for this entire things. Like, for instance, I plan to do CMD. Right, so I'm gonna, like, first I'm gonna implement benchmarking, right? So we have something to compare the current performance with, right? Because it's kind of pointless to try to speed up things without even having any machinery or any, like, a setup to compare the speed before and after improvement, because you can't measure the improvement, right? So first I'm gonna try to do the benchmarking, some sort of setups for benchmarking, and then we can do some implementation. So fuzzing is also going to be a thing, right? Because this library is very unsafe, meaning that it just pokes memory, you know, as it wants. And I could do some, you know, safety measures which constantly do boundary checks, but adding boundary checks on each individual pixel axis is actually extremely slow. Right, so what I have in here is the normalization. So I have operation that you give a rectangle to that thing. It just checks if the rectangle goes outside of the canvas, it strips it, it cuts it, and stuff like that. And then it gives you two ranges, and it tells you, okay, you can iterate over these two ranges and access the pixels however you want without being worried that you're gonna do a buffer overflow. And that way you can organize the loops where you never have to do a boundary checks, because you did boundary checks for all of the pixels simultaneously in one operation, right? So you need to access within a single rectangle. You say, okay, check that, check the boundary checks for that entire rectangle, so I never have to do that later. And that kind of works. And maybe there are some bugs in here, or maybe this kind of operation doesn't work for some things, right? And we need a way to sort of like fuzz this entire thing to make sure, like, at least, you know, to check if it's not trying to do anything funny with the memory, because it's a C library and stuff like that. Oh, thank you for the raid, Chris Nova. Thank you. Yeah, we're just like doing graphics in pure C. We're actually doing software rendering, purely software rendering in C, pixel by pixel, without OpenGL or anything like that. And we also trying to compile that to WebAssembly. Well, I mean we already compiled it to WebAssembly. Right, if you guys wanna have some examples of what we're doing, you can go to this website, it's on github.io, Olivets. So we're developing a very simple graphics library in C that renders everything into the memory pixel by pixel. And here we have a bunch of examples that use that library that are compiled to WebAssembly. So you can have, you know, triangle interpolation with gradients and semi-transparent circles. We can have like this 3D thing. We can, you know, scale and squish and stretch the textures and stuff like that. We can have a simple 3D, and all of that without OpenGL or anything like that, pixel by pixel. Of course, it's slow. You can't really put too many triangles in here, but we're doing that just to learn the math behind all of that, right? So if you're interested in this entire thing, there's like a link to the GitHub, and it's complete open source. So yeah. This 3D thing that kills bitrate. Yeah, I'm sorry. So, and yeah, I'm gonna, yeah. All right. So does anyone have any questions? Maybe. Because we're already kind of, yeah, we're already kind of done with everything we wanted to do today. Have you looked anything at coding microcontrollers? I wish I could, but I don't have a microcontrollers, unfortunately. And I don't really have money to buy them. Small game consoles. I don't know what you mean by small game consoles. What keyboard do you use? I'm using a USB keyboard. I really recommend it. Unfortunately, it's a USB 2 keyboard. I know that these days you're supposed to use like USB Type-C, but again, I'm using a computer that is 10 years old and I don't have money to buy a newer one. So yeah, but regardless, what I notice is that the specific connection of the keyboard doesn't really affect your programming skills. This is what I noticed. Like I tried different keyboards and regardless of the connection, it's just like you end up with the same result. I even tried PS/2 keyboard. Do you guys remember this kind of keyboard? They also don't matter, right? Regardless of the connection, you're gonna end up with the same code. It's just like, doesn't really matter. Twitch money is not good. Twitch is not sending me any money. Hello, what programming language are you using? I'm using an imperative programming language. I tried a lot of different paradigms. I tried object-oriented paradigms, purely functional paradigms. And what I noticed is that with all of these different paradigms, when you try to develop actually useful applications, you end up reinventing an imperative language. But since the original languages are not really designed to be imperative, you end up with a very scuffed imperative language. And at some point I decided that, well, if I need imperative language anyway, why not just program in a proper imperative language? And since then, since I realized that, I only use imperative languages. So that's basically my answer. USB-C keyboards? I don't know, is there a USB-C keyboard? Like, I don't know, like I have a very old hardware in here and I don't really follow the new trends in hardware. What I heard is that people are migrating to USB Type-C. That's what I heard. But I don't really know, like I don't have this hardware. Is that true? Do we have a USB-C keyboard? Like, I don't know, I'm sorry. Probably. Oh, so you do have USB Type-C keyboard. Okay, so it is a thing. Do you have any wacky plans for AOC 2022? Not anything related to making content. I'm not making content out of advent of code. That's for sure. Maybe I can, you know, code just for myself, but I'm definitely not going to stream that or doing any videos, that's for sure. Did you try Python? Is easy to understand, also it's functional in OPP. No, I never tried Python. Tell me about it. Is it better than JavaScript? I don't know. Why are you Lewin? Why are you all Lewin? Okay. Have you tried Porth? I never heard of it. What is Porth? You can do OS-related programming with Python. I wonder how we can do that, though. It's just like you can run an interpreter in the kernel mode. Is that safe even? I'm not sure. Or you can maybe come up with some sort of a compiler for Python that compiles like a limited subset of Python to something like low level, so you don't have to run an interpreter, and then you can claim that you wrote that thing in Python. You know, the PyPy approach, right? So PyPy proud itself for being written in Python, but in reality what they did, they implemented a compiler for a limited subset of Python that compiles down to C. Right, so is it really Python, or is it just like... I don't know, it's just like, it's a matter of definitions, right? So, and if you want to do like operating system stuff in Python, do you like run interpreter in the kernel mode, or you just come up with a small subset of Python that you compile down to something low level? But in that case, is it really Python? I mean, subset of Python. It's just, it goes into like a really weird arguing about definitions of things, and it's just like, I don't know. I don't know. Python is a good language and have a lot of libraries for machine learning and data science. That's actually super cool. But it's slow, does not require compiling, it's a script language. Interesting. I should try it. Have you heard about Julia? I heard like that Julia is, even though it's a scripting language, it's still compilable, kind of. And it also has like a type system. Is JavaScript even JavaScript? Yes. By definition, by the law of identity. By the law of identity, it is JavaScript, in fact. Let's answer the age-old question, is Java interpreted or compiled? That's a good question. It's like, is math invented or discovered? How do you write clean code? That's a good question. It's what is a clean code? It's just like you pick a random adjective and put it in front of code and just ask that question. Okay, is there a website that picks a random adjective? Random adjective online. Is there some website? Generate one. Okay, this is perfect. So, how do you write green code? How do you write embarrassed code? How do you write disillusioned code? How do you write stingy code? Ooh. How do you write gruesome code? What's the clean code? When you say clean code, what the fuck do you mean? Like, I don't know, for me it's word meaningless. Like, you have to have some sort of a criteria of a clean code. I don't know, let's keep generating adjectives. How to write lonely code? Probably by using singletons or something like that. How do you write comfortable code? How do you write unruly code? How do you write frightening code? You see, like, this is actually a very cool website because you can use it to like come up with a marketing strategy for your new programming advice book, right? So there's a book about writing a clean code. I can actually go here and just like generate a random adjective and just like use these adjectives to promote my book. And best code is actually, yeah, that's pretty cool. Seemly code, magnificent code. That's very, very cool. Ambitious code. I don't even know what it means, but you get the point. Like, I don't know what is a clean code. Like, so to understand how to write a clean code, you have to first define what is a clean code and come up with the rigid criteria for what is a clean code. And then just stick to those criteria. That's how you do that. But then you have to ask yourself, why did you come up with that specific criteria, and what are you trying to achieve by picking those criteria and calling these criteria as a clean code? Are you trying to achieve some sort of a specific goal, or are you just coming up with the random rules for yourself to just limit yourself and waste your time? You see what I mean? Do I make sense? I don't know. Since you've gone through enterprise Java jobs, what's your opinion on the whole cargo code development practices? I will still hope and accept any code reviews issues while faking a smile. So essentially, how I treat that is basically like a game, right? So in enterprise, instead of like developing software that actually solves problems, you play in politics game. And what you need to do, you need to understand what are the rules of the game, and you need to outplay other people, right? So your goal is to show that you are the best programmer and other people don't know what they're talking about, and you have to use all means to achieve that, including coming up with random definitions for clean code, right? So essentially you need to come up with a definition of clean code that actually shows you in a better light than the rest of your peers. So yeah. So you come up with some definition of clean code, and then if somebody's trying to tell you that your code is bad, you can say no, it's clean because that and that, and you show them random definitions, and because you use the word clean, it looks legitimate, so people will believe you, right? So that's how it works basically. So you have to remember that in enterprise nobody cares about solving actual problems. Right, so nobody gives a shit. Why do you guys ask me this kind of question? I don't know. I also lost the hope in all of that as well. I mean, otherwise I wouldn't be a streamer. So anyway, don't listen to any of my advices. I don't work in the software industry already for like 5 years, so I have no idea what I'm talking about. All right, so I guess that's it for today, and let's maybe rate somebody. Should we rate anyone? I mean, we got rated today, so we should definitely give back to the community, to the epic Twitch community. How would you recommend an okay or good programming make money online without working for someone? You can stream, for instance. I mean, it's not an option for me anymore, but I mean, you can try. It worked for me for quite some time until some quite weird shit has happened that shouldn't happen in 2022. But it happened anyway. Okay, so who should we rate? Do you guys have any suggestions on who to rate? No Python challenge, holy fuck. That is kind of difficult. I would like to rate Provid, but we already rated him. C++, implement. Now we're talking. A fellow computer scientist. VC Wild. Okay. All right. Is that English? It's Portuguese. I don't speak Portuguese. All right. And Twitch is too slow. I just clicked on software. Okay. Alright, so I tried. Twitch is too slow to do any ratings, so I'm not gonna rate anyone, I'm sorry. Anyway, that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and see you all next time. Love you. Mwah.